The purpose of this demo is to show the new tool, ModelQL, and its capabilities, and how it can impact both development and support of programs written for a relational database such as SQL Server. We're going to start by showing what a program written with standard SQL would look like, and some of the inherent issues and inefficiencies. A program written to provide a predefined set of results can be written in as many ways as the number of developers you have on your staff. The most complex and often miscoded part of any SQL statement is in the from clause, where you have to write the type of join relationships and statements which incorporate the proper key field relationships. If at any point in the future a change is required that may impact these relationships, every piece of code that was written based on those initial set of requirements will need to be modified, tested, approved, and then implemented. ModelQL will change all of this. Our concept is to reference a conceptual data model built on those initial requirements, and then if a change is later required, i.e. from an outer join to an inner join, only one change is required, and that's the data model. All the written code remains unchanged. The conceptual data model is built from a physical data model that can contain thousands of tables, where only a few tables may be required to meet those initial requirements to provide a specified result set. We will start by viewing some of the code, as you see here, that a typical developer would write using standard SQL. Then we will open up the model builder, add a new table to the model, run the existing program. We will then change selection criteria and include a new table with new fields. And we'll rerun the existing program to show that nothing has changed and a different result set is obtained. You do have the option to either manually add the additional fields to the query, or you could use the code generated by our query builder and simply copy and paste the new code. So again, we're looking at the from statement that is in a standard set of SQL. We're now going to go over to our query builder tool. And we're going to connect into our local database, but we do have the option to connect into a hosted database out on the cloud, but we're going to connect into our current local machine. And I have a predefined model already set. So we're going to open up our data model. I simply double click on the data model. And you'll notice we have 5 tables in here. I'm going to remove this table. I'm going to save the data model. And you'll notice that this is currently an inner join. We're going to change that to a left outer join. We're going to now save that. And this now matches the code which was originally set here, where I've got inner joins and a left outer join on the product vendor table. So that table is now set. So now if I were to open up our query builder, and open up a query that I previously defined, you'll notice that it's the same data model we're referencing. We had a predefined set of fields that we're looking at, and this is the left outer join that we have here. I can show you we have the sorts, ascending or descending. We're going to take a real quick look at the DMSelect statement. The DMSelect statement is the ModelQL version of the code, and our interpreter intercepts the DMSelect and knows how to reference the data model. At the same time, we have standard SQL, which we use to cut and paste into the code that we were showing earlier with the inner and the outer joins. So there's your left outer join statement right there. Okay. Now let's run this code and see what happens. Simply select this. It's going to run. We have 500 records. We're going to go back over to our code, run the same query, and you'll notice we get, again, the 500 rows of code with those first top 6 rows where we have a match to the minimum order quantity. And again, if I go back to my ModelQL query builder, we have those same 6 rows where we've got that same result set. I'm going to close this now. Now we're going to go into the data model and make a change to the data model and then see what impact that has on our query. Let's close that down. Now we're going to go into the data model. We're going to add in a table. And we're going to add it in from our AdventureWorks database. We're going to look at the purchasing side. We're going to add in the vendor table. We're going to build a relationship between the 2 tables based off of the business entity. And at the same time, we're now going to change this from the left outer join to an inner join. We're going to save the data model. Now we're going to open up our query again. And you'll notice the vendor table is now added automatically into the data model. However, we haven't selected anything from that table, so we're going to select the name from the vendor table, and I'm going to give it an alias. Name. But at the same time, I'm going to give the name of the shipping method a name this as well. We're going to give it ship name. Okay, now let's take a look at the query text. Our select statement hasn't changed. However, the SQL statement up here has now changed to an inner join. We'll see right here. And if I run this, my result set should be totally different than the one we just ran. Let's run this statement, and boom. Now, instead of 500 rows, I now have 6 rows. As you can see, I didn't change anything in our code. So what we're going to do now is we're actually going to take this code, we're going to copy it, we're going to go back over to our code here, and we're going to insert that statement into here. I can run through the breaks, but I'm just going to run it. And there's our result set, and we have, again, 6 rows returned instead of the 500. And you'll notice I didn't change anything. To make sure that we have the same code, we're going to go back over to here. We're going to pick up the normal standard SQL. We're going to copy it, come back over to the code. We're going to insert that. And it's not formatted, but it's the same code as you saw. I just copied it in. And we're going to run it. And there's the result set, the same result set that we just did. So as you can see, I didn't have to change anything in my codes over here. The normal DMSelect would not have changed because there's none of the inner join and the relationship data in the statement. It's strictly the DMSelect from our model. And that is the power of our code. Our code doesn't change, whereas standard SQL would have changed because of the inner join statement. And we had additional fields. But the inner join statement is what caused the different result set. But I didn't have to change any of the code written with the DMSelect statement. I hope you enjoyed this time. Thank you.